Good evening everyone. Our next lecture in classical mechanics series is conservation theorem for linear momentum of a particle. As we have already told you that particle means if we can ignore the size of the object as compared to the distance covered by it during the course of motion, then we can say it's a particle. Particle can be even our earth if we are considering its motion around the sun. So size doesn't matter, but the size as compared to or relative to the distance covered by it does matters. So student, linear momentum is, we have already defined linear momentum as P equals mv. And dear student, from Newton's second law is F is the rate of change of linear momentum, that is dp by dt. Student, if we have two conditions, the first condition is say no any force is acting on the particle, means there is no any external agency which can exert force on the particle. There is no any field which can exert force, say gravitational field or electromagnetic field. There is no any force field. So if there is no any kind of source of interaction with the particle, so we can say there is the force F is 0. In that case, we can say dp by dt equals 0, and the differentiation of P is 0 implies that our P is constant. It's not going to change. In the second case is much interesting than the previous one. Is if the vector sum of all the forces is 0, again we can say dp by dt equals 0 implies P is again a constant. So student, these are two different conditions. In first condition we can say the particle is a free particle which is free from any type of force. In the second case, various forces may act on the particle, but the resultant will be 0. For example, student, we have a car. This is a car, and when the car is moving, there are various forces are acting on it. Say this car is moving in this direction, it's the direction for velocity. Then student, force of friction is there, drag force due to air is there, and a forward thrust or forward force is also there. And student, if this vector sum of all these three forces, or in other words we can say if this force is balancing these two forces, I can say dp by dt equals 0, P is constant, the car will move with a constant linear momentum. Here constant linear momentum means, dear student, momentum is a vector quantity, and I have written P arrow is equal to constant. In this case also P arrow is constant, means the body is not going to change its momentum in directional aspect as well as it's in magnitude aspect. It is not going to change its momentum, it's also not going to change its direction. Means to change the direction you need a force. And we can say if we have two particles in space, they do not have any kind of reference with the help of which we can say it's at rest or motion. So student, if we have two particles, say this is particle 1, call it as A, and another particle is B. Student, this particle is not moving at all with respect to us, because rest and motion are relative. So we have to say we are observing these two particles A as well as B from very distant place, and we are not interacting with these two particles, and this particle is moving with certain momentum P. As it is free from all kind of field and forces, so its momentum is going to be constant. These two particles cannot see each other, even they cannot observe each other. Then student, they both feel the same thing, although it is at rest with respect to us and it is moving with constant momentum. They will feel the same thing. This particle will feel that it is at rest. It cannot observe its motion. So student, we can say if there is some force, then it can detect a force, or it can conclude that some force is acting on me, or there is some change in my momentum. Even human being, we are human being, we can say we can actually observe the acceleration. We cannot observe velocity. If velocity is constant, if we do not have any kind of source with the help of which we can say we are moving or not, independently we cannot say we are moving or we are at rest. We can just pinpoint the change in momentum. Suppose we are moving in a train and the train is having a closed compartment and we cannot hear any kind of sound. We cannot feel any kind of vibration due to the motion of the train. We cannot distinguish that we are moving or at rest. Sometimes we feel in aeroplane, when our aeroplane is in upper space, upper sky, there is no any cloud, nearby cloud, and we cannot looking downward so that we can find out that we are moving or not moving. In that case, we will feel that our airplane is at rest. It is like suspended in air. Because our body is designed in such a way, we can detect the change in momentum, but we cannot detect we cannot differentiate, or our body cannot differentiate between a zero momentum and a constant momentum. So this was our conservation theorem for linear momentum of a particle. And dear student, basically this conservation of linear momentum is Newton's second law. So law of conservation of linear momentum is equivalent to Newton's second law of motion. Thanks बच्चों.